General adaptation syndrome is also known as stress response. It is an example of the pattern of hormone releases and how they all fit together in their attempt to maintain homeostasis for the body. So it is the general pattern of responses, both hormonal and physiological, in response to stress. Stress is defined as any condition that threatens homeostasis. Now, this can range from strong emotional reactions, like maybe you're really excited, you're having a wonderful time, just the best time of your life. All of that is viewed as a stress by the body. Or maybe it is an extremely fearful situation, one where you were really scared, really concerned that something bad was going to happen to you. In the middle of the range of effects is what an infection does to the body, the toxins that the pathogen produces. On the other extreme, it may be a response to heavy bleeding from a wound. The first phase of the general adaptation syndrome is the fight or flight phase, which we call the alarm phase. This is an immediate response to whatever the stressor is, and it is initiated by the hypothalamus, stimulating the sympathetic nervous system. That in turn is going to stimulate the adrenal medulla to produce epinephrine and norepinephrine, with epinephrine being the dominant hormone. Keep in mind that epinephrine and norepinephrine are also known as adrenaline and noradrenaline, and they have a dual role as both hormone and neurotransmitter. One of the effects of this phase is that glucose is going to be mobilized. Brain tissue is very dependent upon glucose for energy. One of the requirements for the alarm phase is to have increased mental alertness. Thinking back on some of the close calls that I have had out on the highway while driving, or even as a passenger, I can remember some details about some of these incidents that I don't remember about other cars. I remember that big truck was red, and that the driver was wearing a cap, had a white mustache, was wearing glasses. License plate was South Dakota plate with a 46D beginning, and he was pulling a trailer with the dark SUV on the back with pink writing on the window. I was definitely very much mentally aware in that situation as he started squeezing over into the lane where I was right beside him, forcing me onto the shoulder of the road. Secondly, all cells will increase their energy use. Think about what you might have to do in a fearful situation. Maybe your muscles need to be able to move fast and move now. So all of the cells are going to be ready for that activity. Some of the ways in which they are going to be ready is making glycogen and lipid mobilization imperative. That means we're going to liberate the fatty acids from the triglycerides, and we'll probably start breaking glycogen into glucose. This is especially true of the skeletal muscles and the heart. The heart is going to be pumping much faster in an effort to make sure that the cells get oxygen for this increased ATP. A third thing that is going to happen is that non-essential functions are going to be diminished. What's non-essential? Well, Is it really important that your digestive tract be very active during this situation? Probably not. If you recall a time when you have been really, really nervous and you have butterflies in your stomach, it's probably a response to the alarm phase. Other systems that would be carrying out non-essential functions would be the urinary system and the reproductive system. The second phase of general adaptation syndrome is the resistance phase. This is going to occur if the stress duration is more than just a few hours. It is initiated by hypothalamic releasing hormones. The three that are most important are corticotropin releasing hormone, growth hormone releasing hormone, and thyrotropin releasing hormone. I'm going to talk about each of them individually. Corticotropin releasing hormone is going to stimulate the release of ACTH, adrenocorticotropic hormone, which in turn will stimulate the adrenal gland to produce cortisol that is going to promote gluconeogenesis. Remember, gluconeogenesis means that we are going to generate new glucose. This is going to happen in the liver cells, and also it will promote lipolysis. Lipolysis meaning we're going to break down triglycerides. Lastly, we'll catabolize proteins into amino acids, and all of those activities result in molecules that can be used for ATP. In the case of the lipids and amino acids, they can be used in place of glucose. Growth hormone releasing hormone is going to stimulate the release of growth hormone that stimulates lipolysis and glycogenolysis. We're going to break down the glycogen as well. That's where we will be releasing glucose from the glycogen. Thyrotropin releasing hormone is going to stimulate the release of TSH from the anterior pituitary to promote secretion of thyroid hormone. Thyroid hormone has a permissive effect on growth hormone, so it's understandable that the two are going to work together to produce more ATP. Permissive effect means that without the thyroid hormone, the growth hormone won't work, or vice versa. The whole goal for resistance phase is to maintain blood glucose level in order to keep the nervous system functioning normally. Finally, when all else has failed and homeostasis cannot be restored, the body will enter the exhaustion phase. At this point, the lipid reserves are depleted. Prolonged high levels of hormones produces detrimental effects. These effects include atrophy of the muscle, in other words, wasting away, suppression of the immune system, ulceration of the GI tract, failure of the beta cells of the pancreas, meaning that insulin cannot be produced. The effort to conserve sodium and maintain body fluid balances causes the loss of potassium, leading to action potential failure of both the nerves and the muscles. Exhaustion phase ends upon death.